This is our group project with David, Matthew, and Jason. A company wants to review orders substantially larger in value than their usual transactions to ensure company performance and customer satisfaction are consistent even on large orders. We were given 3 Excel files to work with. The first 2 contain order information, which includes the quantity of each product ordered, the order date, and pricing information. The third Excel file contains a list of products by ID and category. Our task was to identify the large orders so they can be supplied to management for review. Using the sales info provided, we identified outliers. The outlier order is those who have a z-score that is greater than 3. We then included the product details of the items and the orders in the final output. We approached this project methodically, dividing the work into several distinct steps. Each step was designed to ensure we could handle the data effectively and accurately identify the large orders. Step 1 was to import and prepare the data. We first started by bringing the 3 input data sets, 2019 and after sales, pre-2019 sales, and product data into our workflow as separate data streams using the input data tool. The first step we took to prepare the dataset was to handle null values by utilizing the data cleansing tool to cleanse the pre-2019 sales. In the data cleanse tool, we selected the field discount to cleanse. We identified and addressed null values by replacing them with zeros. Then we trimmed any leading and trailing white space from the data fields to ensure consistency. This step was crucial to avoid any inconsistencies that could affect our analysis later. Step 2 was to combine the datasets. We first combined the sales datasets, 2019 and after sales, and pre-2019 sales, using the union tool to stack the datasets on top of each other, aligning them by their column names. There were no configurations necessary for this tool. This combines the datasets into one, with all records from each dataset included. Using the combined dataset, we used the join tool to merge the dataset with the product data dataset, using the primary key from both datasets, product ID, integrating records across datasets. The resulting combined dataset contains 7,944 records and 10 fields. Before proceeding further, we performed an additional quality check to ensure that the joint operation was successful. We carried out a validation process where we cross-referenced records from the combined dataset with the original datasets to verify the correctness of the merge. This step ensured that our analysis would be based on a complete and accurate dataset.
With our combined dataset, we calculated total order spend and total product spend as specified in the solution sheets. The total order spend tracks the sum of all expenditures per order, and total product spend tracks the sum of all expenditures per product category. To calculate total product spend, we use the formula tool. Using the formula tool, we applied the discount rate and multiplied the quantity and the unit price to calculate total product spend. We made sure to change the data type to a double while also rounding to decimal places in the formula tool. We then utilized a sort tool to have the output be organized based on order ID ascending. Next, to calculate total order spend, we use the summarize tool. Using the summarize tool, we grouped the order ID, then summed total product spend to calculate total order spend. After, we utilized the sort tool again with the same configurations as the sort tool after the total product spend. Additionally, we verified our calculations by cross-referencing the fields in the solution sheet to ensure accuracy and consistency in our metrics. To isolate any outliers, we calculated the z-score. First, we used the summarize tool to calculate the average and standard deviation of total order spend. Then we used the append tool to append the average and standard deviation to each order ID. Using the formula tool, we subtracted total order spend and the average, then divided the same difference by the standard deviation to calculate the z-score for each order ID. For this formula tool, we also made sure to change the data type to a double while rounding to 2 decimal places. We filtered the dataset using the filter tool to keep only those records with a z-score greater than 3. The true output would give us the records that had a z-score greater than 3, while the false output would give us any output that was not in the true output. After filtering, we retain 89 unique orders. These outliers represent the orders with significantly higher values compared to the rest, indicating orders larger in value than their usual transactions.
Now, with our reduced dataset, we joined the true output with the previous dataset using the order ID as a primary key. We made sure to change the product ID data type to a VW string for calculation we will need for further analysis in the summarized tools. We now branch into detailed analysis specific to each sheet, all items, order info, and category information. The first analysis displays the entire dataset, so we did not do any further calculations. We only used the sort tool to display the records by order ID in ascending order. The second analysis was to calculate the total items purchased and total orders spent for each order ID. To do this, we used the summarize tool. Using the summarize tool, we grouped by order ID, then concatenated the corresponding product ID. Then we calculated total items purchased for each order by summing the quantity. For the third analysis, we grouped by the product category, then the product subcategory, and counted the number of products sold for each product category and product subcategory. This analysis provides a breakdown of which categories and subcategories are contributing most to the high-value orders, offering insights into product performance and customer preferences within these larger transactions. This information can guide inventory and marketing strategies to better cater to high-value customers. In the first analysis, we can sort the total orders spent in descending order to identify which customers have generated the company the most revenue. We can see that customers 3075, 2107, and 2571 are the three largest. With this information, we recommend that the company continue to focus sales on these customers as they spend the most. Conversely, customers who do not spend a lot should have more marketing targeted at them in order to generate more revenue from them and to retain them. In the second analysis, sorting total orders spent in descending order again allows us to see which order IDs resulted in the highest revenue for the company. Referencing the product IDs that correspond to this, we can determine which products make up higher portions of the company's revenue. For example, with order 37252, we can see that the customer ordered 360 items composed of products 16296, 16527, 16697, and 16706. Additionally, in sorting total items purchased in descending order, we can see that the products corresponding to order 43745 are purchased the most often. This data can help the company when they are allocating production resources. In the third analysis, sorting the count by descending and product category and product subcategory by descending, we can see which product subcategory was generating the highest amounts of quantity sold. As seen in our data, office machines had the highest amount at 22, while the lowest amount was scissors, rulers, and trimmers. By utilizing this data, we can prioritize which products to improve and focus on more in the future, and which products we can maybe abandon to provide greater efficiency for the other products. Finally, some suggestions we recommend for the management report include seasonality and store location. Knowing the seasonality of when each purchase was made can give management an idea of the high periods of growth and sales and the low periods. This can help management prioritize their inventories and make sure they are not overstocking inventory in periods of low sales volume that can be estimated. Also, by addressing which store location each product was bought, management will be able to identify which stores to promote more and which stores to have excess inventory. Overall, we feel like these two factors can help increase sales and help when estimating how much of a certain product will be needed. Thank you.